is SATCOM? Something you may not know is that there are tens of thousands of commercial and military satellites that are tens of thousands of kilometers orbiting above the Earth, each capable of providing and supporting a variety of functions. We are going to help you understand a little more about what those functions are and their purpose. SATCOM systems require the use of satellites positioned in space to enable voice and data telecommunications from one part of the world to another.
A satellite is any object that revolves in a curved path around a planet. There are two major types of categorization when it comes down to satellites. One is natural satellite, and the other is artificial satellite. A natural satellite is any celestial body in space that orbits around a larger body. Satellites that are made by people and launched into orbit using rockets are called artificial satellites. How a satellite works. Satellite communication consists of three main components: uplink, satellite transponder, downlink. An uplink, earth station or other ground equipment transmits the desired signal to the satellite. This satellite transponder amplifies the incoming signal and changes the frequency. This satellite transponder transmits the signal back to downlink earth station, and the ground equipment receives the signal. Satellite communication uses ground stations to send and receive microwave signals between artificial satellites, which are in orbit around the Earth.
The first area we will briefly touch on is space.
Satellites are placed either in low Earth orbit, medium Earth orbit, or geosynchronous Earth orbit. These three orbits are illustrated here.
When we look at the space element, we are primarily concerned with the capability of the particular satellite or spacecraft's ability to support the necessary operational requirements and more when the need arises. The element we are particularly interested in is the hardware that is fused together to provide the capability. That fused hardware is known as the payload. The payload is essentially the combined configuration of attached transmit and receive capable antennas, of which there may be multiple, and the internal electronics that pass signals around inside the spacecraft. Because some of these spacecraft are in orbit as far as 40,000 kilometers above the Earth, the electronics on board need to amplify the received signals with enough power to reach the required destinations. Satellites that are selected to fulfill tasking as the conduit for receipt and retransmission of received data and media are often referred to as a bent pipe. This term comes from the order in which signals are received and then retransmitted. Shown here in our simple diagram of data transmissions, after receipt of the signal, the uplink signal is then amplified, translated to a downlink signal, re-amplified, and directed back to Earth via high-gain antennas. It flows in a similar fashion to that of a bent pipe in space. Next, we will take a look at the ground element. When we talk about ground in SATCOM, we refer to anchor stations. So what are anchor stations and what is their purpose? When we hear the word anchor, we often associate it to something that we drop in the ocean floor to help assist with keeping a ship or boat stationary. Anchor stations effectively handle many types of communication traffic that is essential to day-to-day business for our deployed assets and personnel to operate and achieve tasking effectively. In addition, anchor stations also provide local loopback facilities to permit communications between smaller SATCOM terminals which would not be possible due to power constraints. The stations also provide patching and switching connections to a variety of terrestrial networks via cable, fiber optic, and microwave links, or laid infrastructure to funnel data and information across a variety of networks. Now we shall take a look at terminals. There are many types of terminals that are in use across the services to support the many and varying platforms and environments requirements. For each environment and the capability of each platform, we need to take into account size of the platform or asset and the requirement to get communications to it. Not all SATCOM terminals are the same. Again, factor the requirements for some platforms to stay mobile or even be inconspicuous pending the environment it's tasking may take place within and limitations on the size of certain hardware that it can carry. Which now brings us to gaining a further insight into how SATCOM supported communications works.
Satellite terminals and their major components and functions. Before we jump into the major components and functions, we should first talk about the three components of a satellite terminal subsystem. The ODU, or outdoor unit, refers to the set of antenna equipment that is placed outside of the building. The ODU typically includes a satellite dish, feed assembly, L&B, and block-up converter. The IDU, or indoor unit, processes the receive and transmit signals from the satellite. Typically, the IDU will consist of a rack case with a modem for modulation and demodulation of a satellite signal. It may also contain an encoder and decoder for video signal transmission and reception. A power supply and laptop computer can control the terminal, and satellite pointing tools may also be integrated into the rack case. The IFL, or Inter-Facility Link Cable, is a cable system that is used to connect the outdoor unit and indoor unit. IFLs are usually coaxial cable, but may also use other technologies, including fiber optics and Ethernet. As you saw with the three components of the satellite terminal, there is more to them than meets the eye, and they can be used for many different applications. Now let's talk about the two types of satellite terminals. Portable satellite terminal is a satellite terminal that can be disassembled easily. Portable terminals range from 30 centimeters to 2.4 meters and use a tripod mounting system to support the unit. Fixed antennas are stationary and mounted to a king post or non-penetrating mast mount, which can be weighted down, securing the antenna. Now that you know about the two types of satellite terminals, we can talk about the differences between the two categories of satellite terminals. An auto-acquire terminal is a fully motorized system and uses integrated pointing tools to acquire the satellite and peak the signal. The benefit of an auto-acquire system is that it is very quick to assemble and deploy. Assisted acquire terminals are manually pointed by the operator. Pointing tools to assist the user to acquire the satellite and peak the signal may consist of a GPS, compass, inclinometer, DVB receiver, narrowband power meter or received signal strength indicator, and a spectrum analyzer. The benefit of an assisted acquire system is that it is lighter and faster to deploy with an experienced user than an auto-acquire terminal. As you can see, the two categories of satellite terminals are manual and automatic, but there are three physical adjustments you can make on your satellite terminal to lock onto the signal being sent from the satellite. The azimuth is the compass bearing relative to true north. Compass bearings are measured clockwise in degrees from north. For azimuth adjustments, you typically loosen the main mount bracket and swing the dish in a circle, or for auto-acquire systems, the azimuth adjustment is motorized. Satellite terminals will receive and or transmit on horizontal, vertical, or circular polarization. Typically, rotation of the feed assembly will adjust the polarization to match the satellite's polarity. Elevation refers to the angle between the beam pointing direction and the local horizontal plane. For adjustment, the satellite terminal has an elevation rod, which allows you to move the reflector up and down on the vertical plane. Now that you have a little background on satellite terminals, we can now talk about the major components of the satellite terminal. The satellite terminal has an antenna reflector, also known as the dish, which is made from aluminum, fiberglass, carbon fiber, or steel. The purpose of the antenna is to capture a signal from the specific satellite and send it through the feed assembly. The larger antenna you have, the more signal is reflected into the feed. The feed horn at the front end of the waveguide channels the incoming and outgoing signals from the antenna. Orthomode transducers serve either to combine or to separate two orthogonally polarized microwave signal paths. OMTs are often used with a feed assembly to isolate polarizations of a signal and to transmit and receive signals to different ports. The buck upconverts the signal, and the SSPA amplifies the signal from the modem that is directed to the satellite transponder. The LNB receives signal from the satellite collected by the dish, amplifies the signal, and downconverts the block frequency to a lower intermediate frequency. The output of the LNB goes to the modem. The base unit has been designed for outdoor operation and contains major electronic components, such as computer, modem, power supply, and pointing tools.
This diagram illustrates the components that process and converts the information throughout the full path in a communication link. The information is converted by a modulator to a generic band, in particular L-band, before it is transmitted to the satellite. Then, the signal is converted to a higher frequency and amplified in one of the satellite bands by the buck, for example, from L-band to Ku-band. The output signal goes through some filters to reduce interference and add the polarization, and then the antenna will send the signal to the satellite. Once the signal is received by the Earth station, it is processed the same way, but in reverse order. The signal is filtered, amplified, and the frequency is converted to a generic band, in this case L-band, by a low noise block, or LNB, and finally converted by a demodulator or satellite receiver to recover the original information. There are other components in the market known as up-converters and solid-state power amplifiers, abbreviated SSPA, that can do the two main functions of the buck, the frequency conversion and amplification, separately. Depending on your application, it might require using them instead of a buck. Another similar case is the LNB, where the amplification and frequency conversion can be done by a low noise amplifier and a block down converter, respectively. Modems is a combination of a modulator and a demodulator within the same device.